Hello Science 30s. I wanted to do a video about organic chemistry, and we're in our first topic in organic chemistry, which is going to be the halogenated hydrocarbons. What we're going to be focusing on today is the uses of halogenated hydrocarbons. We'll go over, first of all, I guess, a review of what a hydrocarbon is, and then we're going to be talking about some specific halogenated hydrocarbons. One thing that we will not be focusing on so much in Science 30 that we normally would be is naming. We will be doing basic naming, but we're not going to focus on doing in-depth naming in this course online because it's just something that we can focus online to at least know what these things do as opposed to what they're called. So first of all, a hydrocarbon. So hydrocarbons have only carbon and hydrogen. So we're going to take a look at a very simple structure here, a very simple hydrocarbon called ethane. And the ethane molecule, ethane, is actually in your data booklet, so we'll take a look at that later. And it has two carbons which are bonded to each other. Now remember from our bonding capacities that carbon has another 3 bonds available to it, so 4 total. Hydrogen can only ever have 1 bond coming off of it, and so this is the structure of ethane. So we have 2 carbons and we have 6 hydrogens, and so this would be ethane, which would be C2H6. And there we are. Now, when we get into halogenated hydrocarbons, the difference here now is that we're taking as many, there is no set number, we're just replacing hydrogens with halogens. And if you remember from Science 10, here are your halogens right there. So group 17. So halogens are group 17. And so that's not the hydrogen on top, but starting with the fluorine, the chlorine, the bromine, and the iodine. Those are your mainly the big 4 halogens. And astatine is more of a metalloid and has a lot of weird things going on with it, so we don't usually talk about that guy too much. So yeah, let's get into what a halogenated hydrocarbon is. So once again, what I want you guys to be able to do is to recognize this. You don't necessarily need to know how to name it, but anytime you see any halogens in place of a hydrogen, so again, we're looking to see, okay, carbon, carbon, we see a carbon here, we see a carbon here, we see 1, 2, 3, 4, 5 hydrogens, and then we have 1 chlorine, and that chlorine is a halogen, and so this is a halogenated hydrocarbon. And of course we could replace, for example, this hydrogen with a fluorine. We could replace this hydrogen with a bromine. We could replace this hydrogen with a bromine, and then that would also be a halogenated hydrocarbon. And so obviously we could maybe we should just practice on your own, drawing a couple of those and just being used to looking at them and being able to recognize those as halogenated hydrocarbons. Now there is another type of halogenated hydrocarbon I really want you guys to get to know, and that is the CFC. And so I have that down here, chlorofluorocarbon, which is a CFC. So CFCs are pretty interesting. They were invented in the 1930s, right about a time when people, at that time, fridges were around. Not many people had them. We're not talking about even icebox fridges here. Like, these were fridges that were using chemicals such as ammonia, chemicals that were very toxic, and chemicals that were very flammable as well. And so there was many stories from the time of people dying from either the gas building up in their house or the gas blowing up in their house from the refrigerators. And so this new brand or this new type of gas was invented, and it looked something like this. A little bit of a different, there's all sorts of different structures we could have here, but this would be one type of a CFC. And so CFC, here's your chloro, your fluoro, and your carbon. So it has a chlorine, fluorine, and carbon. There could be a hydrogen in there as well. And so once again, these were labeled as non-toxic and non-flammable. Now, it's interesting because they obviously were part of refrigerators then for 50 or 60 years. And it wasn't until the 90s that we realized that these things actually are quite harmful. And the classic story of how when they were trying to sell this chemical, classic story back in the day was a guy named Thomas Midgley who took an entire lungful of Freon, the main refrigerant, and blew out a candle with it. And the idea of that was, again, just to prove that he could breathe it into his lungs and not die from the toxicity. And then he could also use that gas and blow out a candle with it so it would not start on fire. And so, of course, back to the environment, what they didn't realize is that these CFCs were starting to build up. So they were starting to build up in the atmosphere, and winds were taking them way up to the stratosphere where the ozone layer is. And what landed up happening, when those CFCs get to the stratosphere, the sun, this is a diagram from your textbook, the sun, there's more UV radiation up in that stratosphere, and it will actually break apart the CFC molecule. And we land up with something called a free radical. And so this chlorine is now just free to react with whatever is around it. And in this case, that's the ozone layer. And it started to break the ozone layer down. And scientists were not very sure at the time if it was irreparable or anything like that. But there is definitely evidence in the last few years, since we've stopped using CFCs as a society, that the parts of the holes in the ozone layer have actually started to repair themselves. And so we'll just end off this video with just some just very brief list. There's way more things that CFCs do, or sorry, halogenated hydrocarbons, but CFCs again are just one type of halogenated hydrocarbon. But some of the uses that we see in society still for halogenated hydrocarbons: refrigeration and plastics. We see them being used in paints and in solvents, and also in pesticides, pesticides such as DDT, which we'll talk about in a future video. And so that's halogenated hydrocarbons, and have a great week.